Video, let's understand differential equations. But before we understand differential equations, we have to know what an equation is. An equation is a mathematical statement where two expressions are equal. These two expressions are kept on the left hand side and right hand side of the equal to symbol. So x squared minus 3x plus 3 equal to 0 becomes an equation. Whereas x squared minus 3x plus 3, only the left hand side will be an expression. The right hand side may be an expression or it may be a constant. Likewise, sin x plus cos x equal to 0 is also an equation. X plus y equal to 7 is also an equation. Now that we know what an equation is, let's understand what a differential equation is. So an equation which has derivatives will become a differential equation. It is as simple as that. An equation with derivatives is a differential equation. Now this derivative will have dependent variable and an independent variable with respect to which we calculate the derivative. So the independent variable, as the name suggests, it varies independently, and the change in the independent variable will affect the change in the dependent variable. So the dependent variable depends on the independent variable. So write dy by dx. So x is the independent variable and y is the dependent variable. Now let us see some examples of differential equations so that we will understand them better. So here are some examples of differential equations. These are very simple to equations, but they have got a term of derivative. So here you have got dx and dy. Here we have got derivative of second order, dy by dx, dy by dx. So if the expressions in an equation have derivatives, it becomes a differential equation. Here also we have got two terms of derivatives and therefore this is also a differential equation. Likewise, equation number 5 is also a differential equation. Equation number 6 is also a differential equation and equation number 7 is also a differential equation. Now that we know how to identify differential equations, let us see what are its different types. Depending on the number of independent variables with respect to which we have calculated the derivatives, the differential equations are categorized into two categories. First is ordinary differential equations and the second is partial differential equations. So ordinary differential equation is an equation which involves derivatives with respect to only one independent variable. So if we have only one independent variable with respect to which we are calculating the derivatives, then it is an ordinary differential equation. Whereas if you have more than one independent variable, then the equation will be called a partial differential equation. So let us see some examples and identify whether the equation is ordinary differential equation and whether it is a partial differential equation. So look at the first example. First equation, if we convert it into the form of e raised to x plus e raised to y dy by dx equal to 0. I've got this by dividing left hand side and right hand side by dx. So here you see that I am calculating the derivative only with respect to one independent variable, which is x. And whenever you have only one independent variable, then this is of the type of ordinary differential equation. Look at the second example. Here also we have got only one independent variable, which is t, right? And we are calculating derivatives with respect to t. So this is also a ordinary differential equation. Look at the third example. In the third example, we have calculated dy by dx. So x is the independent variable. Again, we have calculated dy by dx and x is the independent variable. So we have only one independent variable and therefore this is also an ordinary differential equation. Look at the fourth example. dy by dx. So x is the independent variable. D square y by dx square. So again here also x is the independent variable. There is only one independent variable and therefore this is also an ordinary differential equation. Look at the Look at the fifth example. Here we have got dx by dt. So t is the independent variable. Dy by dt. So again t is the independent variable. So there is only one independent variable, and whenever in a differential equation you have only one independent variable, it is of the type ordinary differential equation. Two independent. So we have got two independent variables, and whenever you have more than one independent variable, the differential equation is of the type of partial differential equation. Look at the last example. In the first term, p is the independent variable. In the second term, x is the independent variable. So here also you have got two independent variables. And whenever you have more than one independent variable, the differential equation is of the type of partial differential equation. I hope it is clear. Whatever the derivative term you have in the denominator will be the independent variable. If you have only one independent variable, it will be an ordinary differential equation. If you have more than one, that is two or more than two, then the equation will be partial differential equation. So now let's understand what is the order of differential equation. Order of a differential equation is defined as the order of the highest order derivative in the differential equation. So order of the highest order derivative. What do we mean by that? So let us look at these examples. Let us convert the first equation again. So here you get e raised to x plus e raised to y dy by dx equal to 0. Now here you have got only one term of derivative and the order of this derivative is 1. And therefore the order of this differential equation will also be 1. If you look at the second example, the derivative term is of the order of 2, right? And if you look at the definition of order of differential equation, the order of the highest order derivative is the order of differential equation, and therefore order of this differential equation will be 2. It is the differential equation of second order. Look at the third example. The order of dy by dx is 1, and therefore order of this differential equation will also be 1. Let's look at the fourth example. Here we have got two derivative terms. First is dy by dx. The order of this is 1. And the order of the second derivative is 2. The order of the highest order derivative is the order of differential equation. And therefore, this differential equation is of the order of 2. So to find out the order of differential equation, you have to look for the differential term, that is the derivative term of the highest order in the equation. Here we had a derivative term of order 1 and order 2. So the highest order will become the order of differential equation. Now let us know what the degree of differential equation means. So degree is the highest power. Okay, it is not the order. It is the highest power of the highest order derivative. How do we identify power? Power is if you have a term dy by dx. So this is raised to power of 1, right? So power here is 1. If you have a term dy, same term dy by dx raised to 2. So power here is 2. But order remains the same. This is the order of 1, right? And here also the order is 1. So to identify the degree of a differential equation, you have to look at the power of the derivative. And you have to identify power of the highest order derivative in the equation. So let us look at some examples. First example is e raised to x dx plus e raised to y dy equals 0. Let us transform it. So by dividing by dx on both sides, you will get e raised to x plus e raised to y dy by dx equal to 0. Now look at this example. The power of this derivative is 1, right? And therefore, the degree of this differential equation will become 1. And the order is also 1. So this differential equation is of the degree 1 and order 1. Look at the second term. So the second term has a derivative of the order of 2. But what is the power? The power of this derivative term is still 1, right? So the power is 1. And if the power is 1, the degree of the differential equation will also be 1. So this differential equation is of first degree but second order. How do you identify order? It is the order of the highest order derivative. Order is 2, therefore differential equation's order is 2. But since the power is 1, therefore the degree is also 1. I hope that I am being clear about the order and the derivative. I hope I am being clear about the order and the degree of the differential equation. Let's look at the third term. So there is another very important concept about degree, that it has to be a positive integral index. So it can't be negative and it can't be a fraction. Whenever you have derivative terms in denominators or like this in fractions, you will have to transform the equation and bring it into a form such that all derivatives have a positive integral value. Here we have dy by dx in denominator. So we are going to multiply dy by dx on both sides. And this will give us y into dy by dx equals x into dy by dx whole square plus x. Now, order of both the derivatives is 1. But here we have a power of 2. And therefore, the order of this differential equation is 1. But the degree of this differential equation is 2. Because we have got a derivative with power of 2. Now look at this example. Here you have a term raised to 3 by 2. So first let us square on both sides. So when we square on both sides, this equation will become, let me write it here. So this equation will become 1 plus dy by dx square and whole cube divided by d square y upon dx square whole square equal to c square. We are not done yet because this term is also a derivative term and it is in the denominator. So we need to bring it in the numerator to calculate the degree correctly. So this will be written as 1 plus dy by dx whole square cube equal to c square d square y by dx square whole square. Now we have to look at the highest order derivative. This derivative term is of the order of 1, whereas this derivative term is of the order of 2. So we are going to consider this term. And the power of this derivative term is 2. So therefore, degree of this differential equation will be 2. Can you identify the order of this differential equation? So the order of the differential equation is the order of the highest order derivative. The highest order derivative is of second order. Therefore, order of this differential equation is 2. So to calculate the degree of differential equations, you need to bring the differential terms with positive and integral index and then look for the highest order derivative. Its power will be the degree of the differential equation. Now let us see, once you have a differential equation, how do you find solutions of it? So solution is a value which satisfies the equation. It is just like any other equation's solution. The solutions of differential equations are of many types. The first type of solution is general solution. So this solution has arbitrary constants. Whereas there is another category of solutions which is particular solution. So particular solution does not have arbitrary. A particular solution does not have arbitrary constants. That is, in a general solution, when you substitute values, then you will get a particular solution. So the solution obtained from the general solution by giving particular values to the arbitrary constants is called a particular solution. So for example, if we have an equation d square y upon dx square plus y equals 0. So for this equation, y equals a sine x plus b is a general solution. Why? Because it has two arbitrary constants. There is a and there is b. If you put values for a and b, then the solution will change into a particular solution. For example, if I write a equals 4 and b equals 3, so I have removed the arbitrary constants. Now this solution is free from arbitrary constants and therefore this is a particular solution. Now this is very important. The number of arbitrary constants in a general solution of a differential equation of order n is equal to n. That means if the order of a differential equation is n, then it will have n arbitrary constants. Let's look at this example. So this example, what is the order of the differential equations? The order, if you remember, is the order of the highest order derivative. Here, the derivative is of the order of 2. So, order of this derivative is 2. And therefore, the general solution of the differential equation will have n arbitrary constants. Since it is of the order of 2, the general solution will have 2 arbitrary constants, a and b. Right? Now let's look at the next statement. So the number of arbitrary constants in a particular solution of dE of the order of n is 0. This is obvious because particular solution is free from arbitrary constants and therefore no matter what order the differential equation is, the particular solution will have absolutely no arbitrary constants. The third statement says 1DE has one and only one general solution but many particular solutions. Now this is a very obvious statement. The general solution will be only one. So this is a general solution. But as you will change the values of A and B, the particular solutions will keep increasing, right? So therefore, there can be more than one particular solutions as you will change the value of arbitrary constants. But the general solution is only one. There are other type of solutions as well. The singular solution. The singular solution is a solution that cannot be obtained from general solutions. So this solution cannot be obtained from a general solution by assigning values to arbitrary constants. So these are some special and exceptional solutions for the differential equation. The next solution is linearly independent solution. So linearly independent solution has some conditions. So linearly independent solutions, two solutions of a differential equation are said to be linearly independent if when they are written in this form C1y1 plus C2y2 equals 0. Now this is satisfied only when C1 and C2 are 0. So this just means that they can't be 0. So if C1 and C2 are not both 0, then Y1 and Y2 are called linearly dependent solutions. So if this equation is met, if C1 Y1 plus C2 Y2 equals 0 is met with C1 and C2 not being 0, then they are linearly dependent. And if these two are solutions, if y1 and y2 are two solutions of DE, then the combination written in this form C1 y1 plus C2 y2, where C1 and C2 are constants, is also a solution for the differential equation. Now let us know how to form a differential equation. To form a differential equation, we have to perform some steps. So an ordinary differential equation, if you remember what an ordinary differential equation is, it has only one independent variable. So an ordinary differential equation is formed by removing arbitrary constants from a relation of variables and constants. And the order of differential equation representing a family of curves is the same as the number of arbitrary constants present in the equation corresponding to a family of curves. For example, we have got an equation x equals a cos nt plus omega. So here, if you see, we have got two arbitrary constants. First is a and the second is omega. And to form the differential equation, we need to remove those arbitrary constants. So we need to remove a and we need to remove omega. And we know that order of differential equation is equal to the number of arbitrary constants. And therefore, order of the differential equation for this curve will be of the order of 2. And this is the equation. Now in the coming up videos, we will learn how to form differential equations when the equation is given, and when we have a differential equation, how to find out its solution. So keep watching. Let us meet in the next video.